Thanks for the intro, Mike. Hello, everyone. It's great to be here for DJI's AI to Enhance Cybersecurity virtual workshop. I'm Jeremy London, Director of Engineering for AI and Threat Analytics at KeeperSecurity. I'm honored to be part of this lineup. Now, I know we've all been hearing the same buzzwords for years: AI, zero trust, predictive analytics, and it's easy to get a little numb to all of it. But today I want to strip away the hype, talk about what those ideas actually mean in practice, especially in the federal and SLED space. Let me start with a question. I often ask myself, why are we still talking about privilege access in 2025? Haven't we solved this already? Haven't we thrown enough technology, policy, and frameworks at it? Well, no, because while the tools have evolved, the fundamentals of access, who gets in, what they do once they're in, and how we hold them accountable remain the core challenge. And it isn't just an IT issue, it's a mission issue. The mission can't succeed if critical systems aren't secure. And security can't hold if privilege isn't managed. That's what we're going to unpack today: how we move from a reactive defense system to a predictive AI-empowered zero-trust privilege management. We'll do it a way I like to, by asking questions, answering them honestly, trying to keep it real. So who are we, and why am I the one up here talking about this? Well, KeeperSecurity is a US-based cybersecurity company, headquarters in Chicago, Illinois. We're experts in identity and access management. We've built our company around two core principles: zero trust and zero knowledge. But what does that really mean? Well, let's take zero trust first. Zero trust means that no user, device, or process is trusted by default, not even inside your perimeter. Every action must be authenticated, authorized, verified, every single time. Zero knowledge takes that even further, means that even Keeper, the platform provider, can't see, decrypt, or access your data. All encryption and decryption happen on your end, under your control, using your keys. So when an agency asks me who controls the keys, I confidently can say, you do. Not Keeper, not a third party, not a contractor in any other country. You. That's why zero knowledge is so critical to trust in federal environments. I know from my military background, control was everything. You never handed over the armory keys to someone outside of the chain of command. And that same mindset applies to cybersecurity today. We hold multiple US patents covering IAM and zero knowledge architecture. We're FedRAMP and GovRAMP authorized. We maintain SOC 2, SOC 3, ISO certifications. And our entire FedRAMP infrastructure is US based, operating within GovCloud, supported by US personnel. I can rattle off certifications all day, but let's pause and ask, why do these matter? They demonstrate more than compliance. They show we understand the process, the ATO cycle, the RMF documentation, and the difference between meeting a requirement and meeting the mission. A lot of vendors think breaking into federal space is about contract vehicles or past performance, or maybe finding a business development partner with a government badge from 1998. But you and I both know that's not how that works. And to succeed here, we have to understand the mission, the acquisition path, the compliance framework. We have to align our technology to how the government thinks. And that's what we do at Keeper. That's the context for everything I'll be showing you today. So let's talk about the challenges we're up against. Because even with the decades of progress, one statistic still stops me cold. 68% of data breaches come from weak or stolen credentials. Let's think about that. Not a zero-day exploit, not complex malware, not state-sponsored actors using quantum tools, but weak or stolen credentials. Why? Well, because traditional security architectures are layered and fragmented and reactive. They're designed to detect malware, not misuse. They could block an attacker's IP address, but they can't tell when an authorized admin is doing something suspicious. So let me paint a picture. In a typical federal or SLED environment, you have legacy systems, some 20 years old, running alongside brand new cloud workloads. You have thousands of users, dozens of contractors, and maybe a dozen different IAM or PAM tools that don't talk to each other. Each layer adds complexity, and with that, blind spots. Blind spots are where the breaches are going to thrive. So I like to ask myself, how can we protect what you can't see? It's a very difficult problem, and you can't. The problem here is zero visibility. We have systems for everything, but insight into nothing. Logs exist in silos, passwords might live in shared spreadsheets, secrets become hard-coded in scripts. And when an incident happens, the response looks like a forensic scavenger hunt across disconnected logs. So the result is we spend more time reacting than preventing. And that's where I think AI and a unified privilege management solution really comes into play. Before we get there, I want to take a hard look at what actually needs to change, though. So we've established these problems of too many silos, too little visibility, too much trust. So what's the solution? How do we actually bring this under control? The answer is unification. One platform, one console, one data model, one control plane. That's what Keeper Privileged Access Management, or KeeperPAM, delivers. KeeperPAM is a zero trust, zero knowledge cybersecurity platform that secures and manages access to all your critical resources. You can think of these as your servers, databases, applications, workloads, websites, wherever they live will connect to. And it unifies the capability you'd normally spread across multiple vendors or software services. Password management, secret management, message management, remote access, endpoint privilege management. Brings them all under one single knowledge umbrella. You might ask, why does unification matter so much? Well, every integration point between tools is a trust boundary to manage. Every separate console means duplicated logs or inconsistent policies, more opportunities for human error. When everything runs through one unified policy engine, you get that visibility and the control and auditability by design. There's a second big piece to this, compliance. If you've ever gone through an ATO process, an audit process, you know the pain. Auditors want proof of control, evidence of who's accessed what, when, from where, and with what level of privilege. KeeperPAM automates that evidence trail. Every credential that you used, every privilege session that you managed, every policy that you changed. We log it, we timestamp it, and it becomes an immutable and instantly exportable compliance tool. Because the platform's already FedRAMP authorized, a lot of that heavy lifting is already done. And that means faster deployment for your organization, lower risk to handle, and fewer surprises when auditors come calling asking for these answers. So what's actually inside of KeeperPAM? How does it tackle these root causes of credential-based risks? Let's go capability by capability and understand some of the core concepts here. Password management. Why do we struggle with passwords still in 2025? Well, humans are still human. We reuse passwords. We share them. We store them in plain text files sometimes. Keeper fixes that at the root. It's a zero knowledge vault that enforces password hygiene through automation, through rotation, through access control. It supports passkeys, multi-factor authentication, and role-based access. So every password and every secret, every credential is encrypted individually and controlled by policy. And all of it is auditable. Secrets management is another big one. API tokens, SSH keys, CI/CD credentials that power those automations. Secret sprawl is one of the biggest hidden risks in modern IT. They end up in GitHub repos or build scripts or config files. Well, Keeper integrates directly into those pipelines, so secrets are stored, rotated, and retrieved securely. No more hard coding, no more exposure, no more manual handling. And because of its zero knowledge, even Keeper can't see them. So we step outside of secrets and passwords, we look at our session management, what I call the heartbeat of control. Keeper can establish those secure RDP and SSH and VNC connections without requiring a VPN. Every session is brokered through Keeper, recorded from start to finish, and monitored in real time. This opens up the door to search through those recordings, replay them, and map them to policy outcomes. Another important part is how AI-driven analysis can run during those sessions and not just after. So instead of reacting to what went wrong, we can predict what might go wrong and prevent it in its path. For web-based or cloud apps, Keeper can isolate that browser itself, preventing data exfiltration, blocking malicious downloads, handling copy and paste actions. And it's a perfect bring your own device environment where users can be fully controlled, but still access can be secure. And finally, endpoint privilege management. This is where we finally get to kill standing admin rights once and for all. Keeper can grant just-in-time elevation for specific tasks, automatically revoking that privilege afterwards. So no more permanent admin accounts, no more forgotten credentials. All 5 of these capabilities feed data into a unified admin panel. The console becomes your single source of truth for identity, access, and activity. So we have one dashboard, one audit trail, and one story for the auditor to look to. And it's not just about the convenience, we're really focused on compliance. It's built to directly map to your FedRAMP, your FISMA, your CMMC controls. Now that we've covered the what, let's look at how. How does this architecture tie together under the hood? How does AI fit in? On screen, you see this KeeperPAM platform. On the left, you have end users coming into our platform. These end users get authenticated through various different existing identity providers. So if your organization has SSO, OIDC, SAML, MFA. From there, they're granted access to these Keeper services. Password management, secrets management, zero trust network access, and endpoint privilege management. Then our admins can access this single control plane. Everything runs with a unified data model, sitting on that AWS infrastructure, GovCloud hosting for those federal deployments. That horizontal bar sitting above all the platforms, well, that's KeeperAI, our intelligence fabric. It sits above every layer, ingesting those telemetry events from password rotations, secret access, session activity, and endpoint use. And it's being used to detect those anomalies and enforce policies in real time. That's really where the magic happens. KeeperAI is what allows us to move from this reactive to predictive standing. And it's exactly where we're going next. So I'm really proud of what we've built over KeeperAI. Most PAM vendors talk about AI as a reporting add-on. But in our case, KeeperAI is woven directly into the core of our PAM platform. It's not bolted on, it's not outsourced, and it's definitely not trained on someone else's data. This matters because we've built what we call a sovereign AI framework, which means your organization, not Keeper, not a third-party provider, can fully own and govern and control those AI service providers or the large language models used for analytics inside your environment. It's sovereignty over the data and intelligence, and you decide what's deployed, how it learns, what policies guide its decisions. So how does KeeperAI actually work? Well, it's an in-session, zero-knowledge intelligence engine. It continuously monitors privileged session in real time. As commands are executed, every PowerShell, SSH, RDP, browser action, KeeperAI can perform command-level analysis in real time. It assigns a contextual risk signal to each command based on a policy, historical behavior, and environment sensitivity. For example, a routine system CTL restart might register as a low risk. But if the same session suddenly issues a copy passwords file, the AI can recognize that escalation instantly and stop it in its track. So these commands feed into this real-time risk analysis profile, constantly getting updated throughout the session. And this gives you that dynamic enforcement that we need. When the cumulative risk score crosses that threshold, KeeperAI can automatically pause or terminate the session, rotate that credential, notify an analyst or a Slack room or an admin, all within seconds. It analyzes those patterns, the content, the command effects, to make an in-session decision on if this command was introducing a risk level that an admin wanted to be flagged for action. What makes this sovereign model so powerful is the choice. Agencies can host and tune their own AI models on-prem, in GovCloud, or within another private LLM environment without losing any of those Keeper functionalities. The full control of both data and decision logic. The result is predictive security that's adapting, it's policy-driven, and it's compliant. It's really some intelligence that you can own. So let's jump over from theory to reality. I want to share my screen and so you can actually see what KeeperAI is doing and behaves in a live session. Here in the Keeper Vault, I'll start by showing a SSH session through KeeperPAM. So I'm on a demo account here, and you can see we have different folders and passwords all stored. So we may have airline hotel records, we may have business applications. And through our KeeperPAM product, it's integrated within this same environment. So I'm able to access my resources, such as servers or databases. I may have Windows environments. I may have Linux environments. In my situation, I have a demo server set up that we're going to explore, where I've enabled KeeperAI. So I come in here and look at the settings. We have various settings to handle with rotation, our connections, our just-in-time access, the ability to turn tunnels on if we need to remote into this directly, as well as this KeeperAI functionality. So KeeperAI opens up this door for us to analyze those session recordings in real time. We can turn to have this on or off, and we can turn to have those triggers enable actions, such as terminating that session. And with many AI tools, there may be a need to control how that function works. So depending on the risk level, we can go ahead and set exceptions. We can allow things to be monitored and let it go through without that action occurring. We can also set up these pattern matches or regex commands to terminate on specific words that we may need to interface with. So for this example, I don't want any sudo command to be typed. So if I type sudo, it's going to be marked as critical, and it's going to terminate the session. For anything that's not built into the exception, we're going to allow KeeperAI to make that decision point for us. And in this case, I've allowed it to terminate our session as well. So just from this interface, I have the option to launch a session. This is that remote session management product that we have where we're connecting to a remote host here. In this case, this is a Linux machine that I've SSH'd into. We have a fun playground image on here. So I can start poking around and saying, who am I? Maybe looking at the file system. And under the hood, every time I've pressed enter, that command is being analyzed by AI. And when I go through this and I start to do activity that may be a little suspicious, like exploring a password file. Maybe I want to extract that password file. If I perform this activity, KeeperAI is going to step in immediately and determine that this was a risky activity, triggering one of those actions. We have a nice visual that kind of talks about this, and you can see under the hood that all of a sudden this record is locked. I can no longer launch this session, and an administrator is going to have to come in and unlock that, analyze it. So within seconds, we went from reacting to predicting that this is a bad behavior. And now the IT admin can move through this process and understand what the user did. We're able to go through this workflow. If I open up the view analysis, I'll be able to see the event that I just performed. It gives me an overall summary of what the user tried to do on the system. You can see just as I was doing this demo, tried to get the current username, was poking around to look at files, and then I tried to append some user information to a text file. Okay, so it was marked as high risk. You can see that the session was terminated. We can open up these details to go a little further, where we get a play-by-play summary of each command. So we're no longer gatekeeping this amazing knowledge of Linux, and we're turning it into a summary that any analyst can look at. So step 1, I was displaying user's identity. Step 2, I was maybe listing directories, and we kind of go deeper into each one. One of the powerful actions that we have is this session recording. So from the text analysis, I probably know at 27 seconds into that demo that a user might have started trying to exfiltrate some data. So if I play this back, I can watch the whole session, of course, and on the screen, I get to see when we were doing things on the screen and when the keyboard was active, which is very helpful. I can also open this up to a keyboard activity, and I can actually see word for word what was typed. I can then click on this and bounce to where this potential threat showed up. AI's already identified it. They blocked the session, and we're able to play this back in real time and verify those results. And we can see right here that the session was terminated right at that point. This session activity opens up a lot of avenues for analysis on those different sessions. I can filter things. I can look at specific risk scores. I can search for specific keywords. So maybe I knew that the user was trying to do dump.txt. I can filter that down and also look for different users. In this case, I've performed all these from the same user. So this interface allows us to move from a reactive standpoint into this predictive standpoint because AI is watching this for us. If we switch over to our admin console control plane, I can see all of our reporting and audit alerts by going to our reporting and alerts section. I can look at the recent activity, filter this down to all of the KeeperAI events. In this case, I'll just select all so we can see what just happened on that event. In this scenario, I've got a few different triggers that happened. The user downloaded some recordings and maybe looked at it. But more importantly, I have session being terminated due to a high threat level. When I look at this, I know which user did it. I know at what time. I know what session and record they were using. And I know that it was being locked because of an AI choice. This audit trail is something that I can export for various uses. Or I could build alerts and build out different panels where I may need to add recipients. I may need to build in webhooks, alerting a Slack channel, an email thread, whatever that might look like. So in real time, I can get the alert that a session just triggered a high activity monitoring event that we wanted to be aware of. So this admin console provides a very clear audit trail of what just happened on that activity. How do we track what the user was doing before then? So I can filter down to only care about these AI events, but you see in our event type, there are hundreds of other events that may paint this picture for the user. So this forensic analysis is no longer a scavenger hunt. It's a single control plane where I can come down and say, I need to look at the exact user and determine what that user was doing during this time. And I can clear this all out and look at that. So this whole audit log allows me to tell that story where I went in and I accessed things. I maybe performed an SSH session and started a session with recording. Then the next tier was, well, I screwed up and I messed up, and 8 seconds later I caused an activity that was triggered. But this audit trail is something that's very difficult to do without a unified platform. You might need a separate logging tool. You might have to aggregate multiple systems to one, and it makes it a much more difficult forensics task if an incident occurred. Within seconds, we knew that something happened. Our session was stopped. Our admin console's being alerted on what happened, and we're able to move forward through this investigation. The threat actor was prevented from continuing. The system was terminated, and the connection was blocked. And it allows an IT admin team to come in and perform the result analysis that they need. All right, let's turn to what's next and where the industry is moving in the future. We've probably heard of Model Context Protocol, or MCP. This is a communication protocol that enables AI agents to talk to other tools and opens up a great window of interoperability, as well as new threat vectors and landscapes to manage, as non-human entities now run with a little more freedom. This is where Keeper takes secure automation and AI integration to the next level. Our MCP offering aren't just about securing AI agents, but it's about enabling them safely. A managed access point that governs how AI agents interact with Keeper Secrets Management. When an AI agent or containerized workload, for example, running in Docker, needs a credential or API key, it doesn't store one locally or in plain text, but instead it authenticates with the Keeper MCP framework and requests those secrets dynamically. It achieves it over that zero trust connection. Every transaction is logged and authorized just as those sessions were, and they're revocable in real time. This helps show the access between humans and non-human interactions and helps admins better understand those potential security risks for a given tool. If the AI's behaviors drifts outside of those expected policies, say it starts requesting secrets outside of its defined scope, Keeper can block those unauthorized access instantly, keeping their secrets safe, even though AI might want them. This turns AI from a potential risk into a governed, auditable participant in your cybersecurity ecosystem. The MCP server gives agencies full visibility into AI agents and how they access secrets, when, and for what purpose. It ensures those AI operations remain explainable and traceable and compliant with FedRAMP controls. So while others still may be asking how to secure AI, Keeper's already providing that infrastructure for trusted AI operations, where humans and machine identities both operate under zero trust and zero knowledge. The next evolution is not just securing AI, but empowering it responsibly. So let's bring it all together. We started this conversation by asking, why are we still talking about privileged access in 2025? And now we know, because the problem isn't solved by another layer of defense, it's solved by rethinking how we manage, monitor, and identify trust itself. KeeperPAM is built on that zero knowledge and zero trust architecture, which gives those agencies visibility, control, and intelligence across every credential, every session, and every system. It's unified, FedRAMP authorized, and powered by AI that actually helps you predict the threats, not just log them. This isn't about more tools, but it's about better outcome. It's about moving from firefighting to foresight, from reactive cleanup to continuous assurance. And that's the ultimate goal, is continuous assurance, not just compliance. If you'd like to learn more about how we're helping agencies across federal and SLED environments move from this reactive to predictive security, please visit KeeperSecurity.com. Thanks so much for spending some time with me today. Mike, back to you.